Hello everyone, now let's take a look at how to model this problem in ABAQUS. So the question states that we need to use a linear triangular elements and all quadratic triangular elements to find the stress under a concentrated load of 1 unit acting on this corner. And for this rectangle, it has a unit length and a unit height, and we need to use the Poisson ratio of 0.3, and the Young's modulus is equal to 10,000 units of stress and strain. Now let's try to simulate it in ABAQUS. So we need to first build a part for this problem. So it's a rectangle. So we go to part module and click create part, and then because it's a plane problem, so we use 2D modeling space, and let's call it rectangle. And then we use deformable because we need to find the stress for this part. And this time we use the shell because we are going to create a 2D plane. And the length of our rectangle is 1, and the height is also 1. So here we put 5. So this approximate size should be close to the size, the dimensions of our part, and hit continue. Now we are here at the workspace, so we are going to create a rectangle. So we click this icon, and then we can input the opposite colors to define this rectangle. So we start from 0, 0 and hit enter. So you can see we have our first point, and then the opposite point is 1, 1, and then we hit enter. Now we have this part, and then in order to exit this sketch mode, so we have to hit middle mouse button, and then we need to hit down, and now we have this part. So we can use this icon to rotate the view to check our part, and then we can also have this predefined views, so you can click and check your model. Now let's next part, we need to mesh the part, so we go to the mesh, and we are going to use the 2 triangular elements. So we need to first put a seed on each edge, so we click seed edge. Then we select this edge and click down. So here we can use that number, and this time we put 1, and then we click apply and click OK. And similarly, we need to put seeds on the other 3 sides and hit down, and then it's already 1 here, so we just click apply and hit OK. So now for the 3rd edge, click down, and then we put 1 here and click apply and OK. Similarly, we select this one and click down, and then we put 1 here and apply and OK. So next part, we need to check, we are going to use triangular elements. So here we need to check assign mesh control, click this icon, and here we need to use triangular. Otherwise, you will have a quadrilateral element. So let's use triangular and hit OK. Then we can click mesh and click yes. Now we have 2 triangular elements. And next we need to assign the element type. So here we are going to use linear first, and then we need to use a stress state. Either use in this course we are going to focus on either plane strain and plane stress. So here for demonstration, I'm going to use the plane strain, and then here we need to use a linear. And then we can see our element is a CPE3. It's a 3-load linear plane strain triangle. This is what we want, so we click OK. And then next part, we need to create a material property. So we go to property, and then we create this. We create a material property. Let's call it material for rectangle. And then we need to go to the mechanical and electricity and elastic. So it's 10,000, and the percent ratio is 0.3. And then we hit OK. Now we have the material, which is called a material rectangle, and then we need to create a cross section. So we need to create a section. So let's use this default name, and here. So we are going to use a solid cross section, which is homogeneous. So let's hit continue, and then we use the material that we defined earlier, which is called material rectangle. And here we are going to use plane stress and plane strain, and we need to tick this and assign a cyclist. So usually we use the default value, which is 1. So it means the cyclist direction. In the cyclist direction, we have 1 unit of the cyclist. So let's click OK. Now we have a cross section. Now next we need to assign this section to this rectangle. Let's click this icon, and then we need to select this region. We can select this by left click the mouse button, and when you are done you can release it, and then click OK. So we created only one section, which is called section -1. So we are going to use this section. So let's click OK. Now we have assigned a cross section for this part. So next we need to create an instance. So let's go to the assembly module and hit create instance. So we already have this part, so we click OK. So this is our assembly, and now we need to create a step to tell the software what kind of analysis we are going to run. So we hit step, and we create a step. So let's call it step static. So we are going to run a static analysis. So we choose the static general and hit continue. Then here we use the off option for the nonlinear geometry, and then we can switch to incrementation tab, and here we can keep its default settings and just click OK. Now we have a step. We can see we have a step here. So then we need to create a boundary condition and a load for this problem. So let's fix this edge. So let's create a boundary condition. So we can create a boundary condition from here and load from here, or we can just go to loads module and click this icon, create a boundary. It's equivalent. So let's call it fixed edge. So we choose mechanical and encapture, hit continue, and then we select this edge, and then we hit done. Then we hit encapture and click OK. Now this edge is completely fixed. Next, we can apply a load here. So it's called concentrated load, right? So we can call it concentrated load. And we are going to apply this load in step 1, step static. So we keep it as it is. And then this time we use the concentrated force. So we hit continue. And then we need to pick a load to tell software which point we are going to apply the load. So we click this node, and then we click done. And here we are going to apply a 1 unit force pointing down. So CF1 represents the force in X direction, and CF2 represents force in Y direction. Because our load is going to point downwards, so we put a negative 1 here. So after you apply the force, you can see an arrow showing the direction of your force. Now we have boundary conditions and loads. So next we are going to create a job. So let's create a job called example 2, and then we hit continue. So here we just use the default settings and hit OK, and then we have a job here in the under analysis in the model tree. So then we click this plus sign, and then we can find our model and submit the job. Submit. So you can see, if you submit a job, you can see the information will be printed here, and the current model is running. So you can check its status by clicking, right-click this and click monitor. So now the job it shows the processor completed successfully. So if you reach this step, it means your model is error-free. And if you haven't reached this step, it means you missed something. And sometimes the software, the ABAQUS will show which part of the information you missed if you encounter error. And once you're done, you can see the software will print completed successfully. The job example 2 completed successfully. And then we can check the results by right click and go to the results. And here we can check this is displacement. So this is the stress. So if you recall that what we discussed in the class for this for the linear element, for the linear triangular element, we know that stress is a constant. There is a constant stress in each element, so we can see it from here. And here, so I wanted to talk about the output for the software. So we can check the stress by clicking this icon. And here we have a stress. This is a stress. And under this stress icon, we have the first one is 1 meter stress. And the second one is called the maximum in plane principle. So it's first, it's a maximum principal stress for your stress state. And here is the absolute value of your maximum principal stress. So you can click, and then it will show the software will show the maximum in plane principal stress here. And if you click, so the next one is the minimum principal stress. And this one is the second principal stress. So you can also check Trisca stress. And this is the hydrostatic stress. It's called pressure in the software. And this is the third invariant, which we talked in lecture 2. So, and if you interested in the stress state for these elements, you can just click S11. This is sigma 11, and this is sigma 22. This is so because this is a plane string state, so we have a sigma 33, and this is sigma 12. Yeah, that's basically these outputs can cover most of your needs. If you wanted to have some apply some new criteria to judge the failure of your part, you can just export the sigma 11, sigma 22, and sigma 33. So now let's go back and see how can we change it to quadratic triangular element. So if you just want to modify the element type, so you don't need to start the entire, you don't need to start the analysis over again. You just need to go to the add mesh module and assign element and select your part and click down. So this time you use quadratic. So here you can see we are going to use a 6-load modified quadratic plane stress triangle. So this triangle will have 3 nodes at each corner and 3 nodes at middle point of each edge. Let's hit OK. And then you can just resubmit your job. Click Submit and hit OK. This is going to recover your previous analysis. So if you don't want your previous work to be recovered, you can just cancel this and create a new job like quadratic. This time you call it quadratic example and hit continue and click OK. So you just submit the job again. And then you can see our job. So the analysis input file processor completed successfully. It means our model is error-free. And now the job has completed, so we can go to results and check the results. So we can click stress. So this time you can see that the stress is not constant because this time we used quadratic elements, quadratic triangular elements here. And another indication showing that we are using a quadratic elements is here. You can see this edge is not linear. We have a curvature here. Yeah. If it's a linear triangular element, you will see a straight line for the displacement. If you want to make sure if there are 6 loads for each element, you can just check, go to the tool and query and check the node for each element. So here you need to select nodes, and then we have nodes here, see, and we should have nodes at each corner, and we also have nodes here, see.